Hello students, welcome to experiencetutor.com. Today's lesson is some basic concept of chemistry part 2, and this is the welcome message. Properties of matter and their measurement. Every substance has unique or characteristics properties. These properties can be classified into two categories: physical properties and chemical properties. Physical properties are those properties which can be measured or observed without changing the identity or composition of the substance. Example: color, odor, melting point, boiling point, density, etc. Chemical properties. Chemical properties are characteristic reactions of different substances. These includes acidity or basicity, combustibility, reactivity, etc. Many properties of matter, such as length, area, volume, etc., are quantitative in nature. Measuring a physical quantity. If we say 10.2 centimeter, it is correct and it makes sense. Instead of saying 10.2, 10.2 itself doesn't make any sense. Therefore, 10.2 centimeter is the correct presentation and it is called physical quantity. Therefore, a measured physical quantity is expressed in two parts. First part is numerical coefficient and the second part is unit. Either of them are meaningless without each other. A unit is a standard of reference chosen to measure or express any physical quantity. The International System of Units (SI). The International System of Units was established by the 11th General Conference on Weights and Measurements. The SI system has 7 base units: mass, its unit is kilogram, its abbreviation is kg; length, its unit is meter, its abbreviation is m; time, its unit is second, its abbreviation is s; electric current, its unit is ampere, abbreviation is ma; temperature, its unit is Kelvin, abbreviation is K; amount of substance, its unit is mole, abbreviation is mol; luminous intensity, its unit is candela, abbreviation is CD. Prefixes in SI system. 10 to the power minus 12 is known as pico. 10 to the power minus 9 is nano. 10 to the power minus 6 is micro. 10 to the power minus 3 is milli. 10 to the power minus 2 is centi. 10 to the power minus 1 is deci. 10 itself is 10 to the power 1 is deca. 10 to the power 2 is hecto. 10 to the power 3 is kilo. 10 to the power 6 is mega. 10 to the power 9 is giga. 10 to the power 12 is tera. Mass and weight. Mass of a substance is the amount of matter present in it, while Weight is the force extracted by gravity on an object. The mass of a substance is constant, whereas its weight varies from one place to another due to change in gravity. The mass of a substance can be determined very accurately by using an analytical balance. Volume. Volume has the unit of length to the power cube. So, volume has units of meter cube or centimeter cube or decimeter cube, etc. A common unit, liter, is not the SI unit. It is used for measurement of volume of liquids. 1 liter is equal to 1000 milliliter is equal to 1000 centimeter cube is equal to 1 decimeter cube. Density. Density of a substance is its amount of mass per volume, per unit volume. SI unit of density is equal to SI unit of mass slash SI unit of volume is equal to kilo upon meter cube or kilo meter kg meter per minus 3 to the power minus 3. This unit is quite large and a chemist often express density as gram centimeter to the power minus 3. Temperature. There are three common scales to measure temperature: degree Celsius, degree Fahrenheit, and Kelvin. Here K is the SI unit. Temperature below 0 degree centigrade, that is negative value, are possible in Celsius scale, but in Kelvin scale negative temperature is not possible. Formula is degree Fahrenheit is equal to 9 upon 5 degree centigrade plus 32. K is equal to degree centigrade plus 273.15. Significant figures. Before we start significant figures, let us know about uncertainty in measurement. There are certain set of rules to present the experimental data and theoretical calculation in meaningful ways, so that we can use numbers easily and data can be made more sensible with firmness to be to the possible event. Scientific notation, significant figures, and dimensional analysis helps us in many ways in representing the data and theoretical calculation. Scientific notation. In chemistry, we study about atoms and molecules, which have very low masses and are present in very large number. A chemist is often concerned with the number as large as mass of an electron for the molecules of 2 gram of hydrogen gas. Similarly, other constants like Planck constants, speed of light, charge on electron, proton, etc. involves very large numbers. It is very cumbersome tasks to write, count, and do the calculation of such huge numbers. But such a problem can be solved by using scientific notation of such numbers, that is, exponential form of those numbers. Therefore, we can write in 10 to the power. Therefore, 175,000 can be expressed as 1.75 into 10 to the power 5. Similarly, 0.17 can be expressed as 1.7 into 10 to the power minus 1. Significant figures. Experimental measurements are generally associated with some extent of uncertainty. However, one would always like the result to be precise and accurate. Precision means closeness of various measurement of the same quantity. Accuracy, on the other hand, is the agreement of the particular value of the true value of the result. But these aspects again depend on measuring device, accuracy of measuring device, and the skill of the person who is performing the experiment. Therefore, significant figures are those numbers of digits in a quantity that are known reliable plus one digit that is uncertain. All the non-zero digits are significant. For example, 3 to 5 has significant figure 4. All zeros between two non-zero digits are significant. For example, 1304 has 4 significant figures. The zero of right of decimal point and left of non-zero digits are significant. For example, 0.0012 has significant figure as 2, whereas 6400 also has the 2 significant figure. Few of the examples are given below. 1234 has 4 significant figure. 86.234 has 5 significant figure. 0.0013 has 2 significant figure. 3100 have 2 significant figure. 23.100 have 5 significant figure. 1.8 into 10 to the power 15 have 3 significant figure. Round off digit. The rule for rounding off a measurement are given below. A. If the digit right to one rounded is more than 5, the digit to be rounded as increased by 1. B. If the digit right to 1 rounded is less than 5, the digit to be rounded remains same. If the digit right to be 1 rounded is equal to 5, the digit to be rounded increase by 1. If it is odd. If the digit right to 1 rounded is equal to 5, the digit is to be rounded remains the same if it is even. Therefore, we can write 1.677 is equal to 1.68. Similarly, we can write 2.6357 is equal to 2.636. Addition and subtraction rule. Before adding and subtracting, all measured values are rounded off to smallest number of decimal places. Example, evaluate 1.368 plus 2.3 plus 0.0653. Therefore, we can write 1.368 is equal to 1.4. 2.3 we can write as 2.3. 0.0653 we can write as zero point 0.1. Therefore, we can write 1.4 plus 2.3 plus zero point 0.1 is equal to 3.8 is the answer. In case of multiplication and division, answer should be in the form of least number of significant figures. For example, we have a sum 2.34 into 10 to the power minus 8 into 10 to the power into zero point 0.5 upon 6.4. We need to write the answer in significant figure. Then we can write the same as 1.17, 1.17 into 10 to the power minus 8, 10 to the power minus 8 and upon 6.4, which will be equal to 0.182828 into 10 to the power minus 8. Therefore, we can write it as 0.2 into 10 to the power minus 8. Because this number 8 is more than 5, therefore we added 1 in its previous number 1. Dimensional analysis. During calculation, we often need techniques to solve problems involving conversion of units from one system to another. The method used to carry out this is called unit factor method or dimensional analysis. For example, a piece of wood is 6-inch long and you are asked to convert its length into centimeter. We know that 1 inch is equal to 2.54 centimeter. From this equivalence, we can write as 1 inch upon 2.54 centimeter is equal to 1 is equal to 2.54 centimeter upon 1 inch. Thus, 1 inch upon 2.54 centimeter equals 1 and 2.54 centimeter upon 1 inch also equals 1. Both of these are called unit factors. A unit factor must have the numerator and denominator representing equivalent quantities. The numerator should have that part in which desired result is required. If the result is required in centimeter, then centimeter should be numerator. In some number, if some number is multiplied by unit factor, it will only affect in other respects. In simple words, we can write information asked is equal to information given into unit factor. Now, let us solve few of the questions. Express the following numbers and four significant figures. A. The fifth figure of the first number is 7, which is greater than 5. Therefore, the significant figure will be 6.609. For the second, the fifth number is 2, which is less than 5. Then the significant number will be 42.39. We'll just drop the 2. Next question. Express the following number into four significant figures. So the answer to the first question A will be 1.812 into 10 to the power 3. Why? Because the fifth number 3 is less than 5. Therefore, we have to drop off 3. The solution for the second question number B will be 8.837 into 10 to the power into 10 to the power minus 3. In the next question, we have to find the sum of 3.368 kg and 2.2 kg. So first what we will do, we will write it as 3.368 and 2.02. Now we'll add it simply 883.5, which can be written as 5.39 kg. Next question is, the mass of a wooden block is 6.932 gram. If the density of the wood is 7.7 gram per centimeter cube, what is the volume? Express the results in appropriate significant figures. So we know that volume is equal to mass upon density. Therefore, we can write 6.932 upon 7.7, which is equal to 0.9002597, which continues, and we can write it as 0.90 centimeter cube. And this is the end of this topic. Please let us know about the video, whether you like it or not, and please subscribe our channel for more and more videos. Thank you.